what is the best reality for my application? How do I decide if I create a virtual reality app or an augmented reality application? Think about your use case. Can your users sit on a chair and be immersed and completely disconnected from their environments and see a simulation for an education purposes, for example? Then that's a very good VR use case. But if you have to have some kind of connection with your actual environments, then augmented reality should be your choice. A great example is if you are educating surgeons for a surgery, that's a really good use case and that you can practice in a virtual environment. But when you're in a surgery room, you can't be disconnected from your environment totally, but you might need to have some relevant information in front of you about the patient. And that's a really great use case for augmented reality.
Hello everyone, hope you are enjoying the event until now. Here Gonçalo, and we will have our recorded session about applications with HoloLens. I will just start the review.
Thank you all for joining my talk. Today we will build a fun little HoloLens demo with the help of Unity and the MixedRealityToolKit. But before we do that, let me shortly introduce myself. My name is Ron Smeek and I'm a freelance HoloLens developer and creative coder. I love working with new technology and exploring new ways of interacting with the digital world. Interactions that go beyond the regular mouse and keyboard. I'm fascinated by mixing the digital and real world in interesting new ways. Today I would like to take you along on a small piece of my journey of exploring interactions with holograms. Last year I looked at hand experiences with HoloLens 2, but this year I decided to take a different route. And to explain that, I would like you to meet Timmy, my co-host for today.
Hi, my name is Timmy. I will be helping Roland during his presentation today. I think he can use a little help.
Thank you, Timmy. As you can see, Timmy here is my imaginary friend that I brought to life as a hologram.
And Roland here is my imaginary creator. But I am not sure if he is for real.
Hey, who's fake here? So, interaction with Timmy can occur at 3 different levels.
Okay. First, when Roland looks at me, I can look back. Secondly, I can also hear when Roland talks to me. Not that it ever makes sense.
Hey.
And finally, I can also recognize when Roland is holding out his hand. But we will come back to that later.
Thank you, Timmy. As you can see, Timmy can look at me, talk to me, and hopefully respond to my hand gesture. So, let's switch to Unity, where we start out with a Timmy that's nice and quiet.
Yes, let's do that. And hope that Roland finally keeps his mouth shut.
Hey. So I opened up Unity. Today we are using Unity 22.3.11. I think we're already at 23, but well, these versions don't differ too much from each other. I imported the MixedRealityToolKit 2.7.2. And I added the character Timmy, which is a basic character in its T-pose. It's coming from Mixamo. I don't know if you're familiar with it, but here's a short overview. You can there are different characters and you can have different animations. And you can try out these animations on these different characters and then finally download as an FBX for Unity, with skin if you need the character, and without skin if you only need the animation. But I already did that in this project, and to quickly show you what it looked like, I created a scene with a simple Timmy controller as the animation controller. You can see here I added a wave trigger. You can add different types of parameters to help transitioning between different animations. So we start out with the look around animation, which is the entry animation. Then there's a transition to the waving animation, and this waving animation is triggered by the wave trigger condition. The exit time is set to false, so look around is we don't wait to look around the lengthy look around animation to be finished, but we directly go to waving as soon as the trigger is triggered. But for the way back, we say there's no condition, but we wait till the waving animation is finished. And in the scene, I added a voice command, speech command, which is here. The keyword is here, hey Timmy. And I respond to that with a speech input handler, or the speech input handler listens to the keywords that are spoken. There's no focus on Timmy required, so I can speak it in any direction. And then it directs to the animator attached to Timmy and sets the wave trigger. So that means if we run the scene and we say, hey Timmy, that he will wave at us. So that's the most basic use of using animations for a character. But as you saw, the character is, well, the animations look quite a bit rigid because they're not directly aimed at somebody, and that's what we are going to change. And to do that, we are going to import a new package. Or actually, I already imported it. It's called Animation Rigging, which is a fairly new package, and it can be used to dynamically adapt rigs to respond to changes in the scene or in the game. You can see there's an animation rigging script entry in the menu here. So let's add a empty, call it head rig, because we are going to make Timmy look at the user. And to do that, we are going to add a rig to the empty and add a component which is called a constraint. In this case, the multi-aim constraint. The constraint object is going to be the head, and we need to walk down to the head. As you can see, this is the head node. The neck, the head's a bit higher. So these are constraint objects, and we want to aim it at the camera because that is where the user is. Okay, we can add some limits, but it doesn't. Sometimes it still doesn't work completely well with the animation, because sometimes the animation, well, makes strange movements, and that combines a bit strange with the head. So I added the multi-aim constraint, the rig, and I also need to add a rig builder script and add the rig to the rig builder. And if we now play this in the editor, we move up a little, you see he is still looking up at us, and if we set the weight down or up, then we can make him look away and continue looking in the direction of his animation, or at the user. And of course we want to control this value from a script. And since Timmy can now look at us, it would be nice if he would respond to us looking at him. And since HoloLens has the possibility to detect eye gaze, we can use that. And there's a few things we need to check. First of all, in the settings with OpenXR, we need to make sure that there is a eye gaze interaction profile activated. Typically the hand is already there and the motion controller are already there, but sometimes eye gaze is forgotten. Oh, and when publishing you also need to set the eye gaze or the gaze input, because it's an explicit capability that needs to be given permission for by the user. And then if we go into the MixedRealityToolKit settings, and we can see that there's the gaze input provider here, OpenXR gaze input provider, but obviously that will only run when used on the HoloLens to simulate things inside Unity. You can use the input simulation service. And typically the default eye gaze simulation is set to disabled, so I had to make a copy of the profile and set it to camera forward axis, which is the middle of the screen, and or using your mouse. In that case you can simulate eye gaze like this. And the thing you also need to check is inside the pointers. If I switch to the default mixed reality input profile, you'll see that eye tracking is disabled. So I've made a copy of that, the Timmy point profile, and enabled it over here. Now let's respond to that by making a Timmy behavior script that will control the weight. If we look at the Timmy behavior script, can see it takes in the look at rig, which is our head rig, and we will control the look at rig weight over here. We'll do that with a smooth damp, and the smooth damp is driven by a dwell active flag. So we'll either go to 1 or to 0 depending on if Timmy is being looked at. So if dwell is active or not. This flag is set in eye focus start and in eye focus stop. So smooth damp is a way to smoothly go to a value with a critically damped way of animation, and it's one of my favorite tools to build a smoothly animated value. Now we need to use the eye tracking to actually invoke these methods. So Timmy is over here. We need a collider, capsule collider. I'm going to use that. And let's see what that looks like. Go to orthogonal. Make it fit the character more or less. Go to the right, you can make it a little bit more narrow. Well, that should be enough, I think. Front. Okay, so we have a collider, and now we can add the eye tracking target script, which will listen to eye tracking events, and we can link those to the script. So we could use onLink at start, but in this script we are going to use the onDwell, which is a little bit delayed way of responding to eye tracking. The Timmy behavior on eye focus start, onDwell, and when looking away, we want to go to invoke the Timmy behavior on eye focus stop. Okay. So dwell is activated after 0.8 seconds, and it's, well, it more or less simulates if you're staring at somebody for about a second, and then he'll respond to us by looking back. Now let's see how that looks like in a demo. So we are in the editor. If we hover the character, he will look at us. Maybe it's a bit clearer if we are above him. He will look at us and he will look away. So we can now stare at him and he will look back at us. In this direction. As you can see, the head looks a little bit funny combined this with this animation. So for the next part of the talk, I would like Timmy to also respond to when we are speaking to him. And as we saw earlier, Timmy can already respond to voice commands, but voice commands typically are triggered after they are heard, so they might take a little bit of time to respond. Then there's also the option to add a dictation recognizer, where you can talk to him and the spoken text is converted to an actual text string, but that's even slower to respond. But for this demo, I wanted to invoke a direct response when we start talking to him. So that's why I'm going to listen to audio input directly. So for that, let's create a placeholder object. Let's create a sphere, add to height. And this sphere will be used to visualize if audio is detected or not. Let's give it a material, audio input material. So the material will be green if there's no audio level detected, and it will become red when audio level is above a certain threshold. Let's call it the talk sphere. And for that we are going to use the microphone input. Now microphone input is a script that I found on the Unity forum. It basically initializes the microphone and listens to the samples being generated, and then calculates an average loudness level. And to process this input, I created an audio level detector script. So this audio level detector script will write back to our audio material to indicate if we're high or low. So there's a flag high or low. Those are public here, so I could do some debugging. And how this audio level detector works is what we're going to see now. So here's the code for this script. As you can see, I'm using two moving averages, which is a different script, which is basically a queue of values that are, and it's a moving window. So you give a number of samples, and then it will take the average each time you enter a new sample. The oldest one will drop out, and the new and the latest ones will be used to calculate a new average. And I'm using two moving averages. So there's a slow moving average that's being used to detect the basic noise level of the basic level of audio in the room. So depending on the microphone or the environment settings, the noise levels may be different. So using an absolute trigger value is error prone. So I'm using two moving averages, a slow one and a fast one. A slow one is basically our base level of audio, and then the fast one will go up and down and fall above, go above the slow one and trigger the high value. And the other way around, when it goes back, then we know it's then there's no longer audio heard. So there's this high flag, the fast and the slow values, and the last time calculation value to limit the calculations to 60 frames per second, because on HoloLens it will this code will run at 60 frames per second, but in the Unity editor it might run much faster. And since I'm testing in the editor now, and I wanted to test how well it would work, I limited it to also 60 Hertz. So I calculate the fast moving average by adding a new microphone loudness value, and for the slow moving average I do almost the same, except that I look at the high value. If we are high, then we don't take in the full microphone loudness, but only the half of it. So the noise level is not rising to the fast moving average, and otherwise we would drop out soon after we start talking. And there's a different high and low trigger. So first let's go to where we start out with. There's no noise in the room, and then we go to high as soon as the fast moving average goes to twice the slow moving average, above twice the slow moving average, and then we'll set the color to red, set the high value to true. So there needs to be some distance between the slow and the fast moving average. So if we are high, so if we are talking, then we only drop back if we drop back enough, and in this case that is half the moving average. So we need to drop, the fast moving average needs to drop down seriously to go back. We set the color to green and high value to false. So that's basically how this audio level detector is working. This is automatically looking at the microphone input because the loudness is a static value. And now let's modify the script. We have our Timmy behavior. We add our audio level detector. I already modified the script. Well, let's see how that looks. So we added the audio level detector here. So, and instead of triggering the look at wait only by dwell active, we now say we look at the user either if he is looking at us or if the audio level detector is set to high. So that didn't change that much, and let's see what it looks like. We're now in editor. Hey. I'm over here. Look at me, I'm over here. Timmy, hey, how are you doing? Hey, Timmy. So that seems to work. He starts looking at us as soon as we make some noise. But of course, to make it symmetrical, it would be nice if Timmy was capable of talking back to us. So that's what I also decided to make. Let's go there. So then we have this. And for that, we are going to use text-to-speech. Text to, and in this case not a regular text-to-speech, but I made a copy of it called Timmy text-to-speech, and this needs an audio source, and we are going to attach the audio source to the head. Audio source. Oh, I forgot to attach it. An audio source is here, and we set the voice to Catherine, which is an Australian female voice. As you may have noticed, I added a lot more voices that are available on HoloLens. I tested that. Text-to-speech unfortunately doesn't work in the Unity editor, but we can set it up here. So I made a copy of the text-to-speech included in the MixedRealityToolKit. So I added the voices. It's no longer required to have the audio source directly at the same component level or at the same game object. And I modified the audio pitch to be a little bit higher and a little bit slower, so Timmy has a little bit more of a squeaky voice. And now we are going to make use of it in the script. So we have the Timmy behavior. As you can see, I already added some text that he can say, and the text-to-speech object should go here. Now, let's take a look at the script. So I regular steps. I added the speak function here, which checks if the text-to-speech is not already speaking. And I added a listen to user flag, which remembers if we listen to the user, because then as soon as the user stops speaking, Timmy can start speaking back. So listen to user is if remembered, if it's already happened, or if the user is not speaking, and if Timmy is not speaking and the user is speaking to us and looking at us, then we assume that Timmy, or then we say that Timmy has listened to the user. Now, when does Timmy speak his text? As soon as the user is still looking at him and Timmy is not speaking, and the audio level detector is no longer high. So if the user stops speaking to Timmy and we listen to the user, then we take the one text out of the array of texts and speak that. We wrap around the current text index to prevent going out of the array, and we set listen to user false. So that should be enough to actually make Timmy respond to us. So let's see how that looks in the HoloLens. So let's see if this works.
Hi everyone, I hope you like this talk.
Hey, looks like you can really talk.
Yes, I can talk. Thank you.
Oh, nice. Is there anything else you'd like to share with the audience?
There is nothing more to say.
Oh, okay. As you may have seen in the demo, there was Timmy was also moving his head, and that's because I added a talking head controller, which is more or less using the similar techniques that we saw before with the moving average. So again, in this case I'm using the audio source that's used for generating or uttering the sound generated by Timmy, and we are monitoring that and taking a slow and a fast moving average again. In this case 10 samples against 20 samples against 10 samples, calculate a maximum level, and we use these levels to compare and to trigger a movement in the head. So that means that the audio that Timmy speaks is used to actually drive the animation, or in this case modify the head node. And important to notice here, this is all running in update, but the actual modification of the local rotation of the node is running in late update. And late update runs after all the regular updates ran and animation scripts have been applied, so that the animator has run, and then we still have a last minute opportunity to change the orientation of the node. In this case, we take the existing local rotation and we apply the smooth movement to rotate the head up and down, and this will generate the head movement to fill in the missing mouth of the character. For the final part of this talk, we're going to look at trying to shake Timmy's hand. And for that, we again are going to use the animation rigging package. So let's first add a new empty and call it hand rig. Up here. Reset. And add a rig. And in this case, we are going to use a 2-bone key constraint. Which we need to give 3 different joints, and the joints that we are going to use are the, let's see, the arms. Where are they? The right arm is the root, right forearm, and the right hand. And then for the source object, we are going to create a placeholder object. Let's call it hand shaker. 1.7.5 and 1.2, and let's orient it like this. Okay, so it's now a little bit in front of Timmy, and we will use that as a target for the 2-bone key constraint. And we can also provide a hint. Let's add a hint. Oh, the hint is already there. And the hint in this case is attached to the right upper leg. And it is used to help positioning the elbow in the right direction if there's room to move the elbow away. Okay, so this is the hint. And then we need to add the rig to the rig builder. And we can also add, I think I'll also add the need for this in the script. Add a hand rig to the script. Well, first let's check how this looks in Unity. We don't run the script. As you can see, Timmy is holding out his hand. And if we control this hand rig again, you can see that he will reach forward. Okay. Now we are going to use this again in Timmy behavior script, and this Timmy behavior script will use a handshake gesture detector, which I created. Let's see what that code does. So the handshake gesture detector is a script that looks at the hand of the user, the hand of the person wearing the HoloLens, and it basically uses the hand joint utils, which is a handy script to quickly access hands that are available in HoloLens. And as you can see here, it also, next to the hand joint utils, it also uses hand pose utils, which is another handy script to calculate curling of the fingers. So this is the pure access of the hand joints, and this is calculation of some derived variables. So what we do in this gesture detector is we try to find the right hand, and if we find that and it's tracked, then we get the palm pose. So the palm pose is the middle of the hand, and we check if the palm is not looking upwards and not looking downwards, but looking sideways with a threshold of 45 degrees or pre-configured variable that I set to 45 degrees. And we have also have a pointing angle to calculate in what direction the hand is pointing. So if the hand is pointing more or less in the direction of the hip joint, or the position where Timmy is going to hold his hand, then it will be seen as somebody holding the handshake pose. This can be tested inside Unity. What's a little bit harder to do is to check for finger curls, so that's why I disabled it in the editor. But when using the HoloLens, you can test for finger curls, or if the fingers are straight, then it's more likely to be a handshake pose than when you're holding up a fist. So that's the detector. This one is attached to the handshaker, and then this handshaker or the handshake detector goes into the Timmy behavior. Now let's see what this does. We can go down here and see that it's more or less does the same as we did with the look at rig. It also sets the weight to a value of 1 when the handshake is detected, or the handshake pose is detected, and it does that also with a smooth bend. And also look at user is now also triggered by a handshake pose. So as soon as I hold my hand out to Timmy, even if I'm not making noise or not looking at him, he will start looking at me and hopefully stick out his hand. So let's see what this looks like in HoloLens. Oh, let's test the hand interaction. It's a little bit sensitive.
Nice to meet you, Roland.
Nice to meet you too, Timmy. As you saw in the demo, we were not only able to make him reach out his arm as soon as he discovered our hand pose, but we were also able to shake his tiny hand. And for that I added a object manipulator to the handshaker script. And the object manipulator is the go-to tool to quickly make objects interactable or grabbable inside when using the HoloLens. In this case we're only interested in near interaction, so we need to add a near interaction grabbable, and we want to disable smoothing because we want to have direct control over his hand. And I also added a trigger to say something. Let's add it here. So this will be spoken as soon as his hand was touched. And also the handshaker, I added an extra script. Let's see where it is, the handshaker controller, which is a helper script to let's see, point and the clamp angle. 45. Which is a simple helper script to point the hand more or less in the direction of the user, so his interaction feels a little bit more fluid and responsive to where the user is. So that concludes my talk. You can find the source code for the demo at the link below. Feel free to ask any questions.
Hey, wait a minute. I think you should give me some real intelligence now.
Sorry, Timmy, we don't have time for that anymore.
Hello everyone, hope you liked what Roland bring us. It was a real specific and detailed step-by-step Unity demonstration. Thank you very much, Roland. And we still don't have any questions from the audience, but I have myself one or two questions regarding what we have seen. One of them is why HoloLens and why not another platform? And another one is how much time do you have to dedicate in order to achieve this level of development skills?
Okay, so why HoloLens? Yeah, that's mostly because I'm working on HoloLens, and when a conference like this shows up, I'd like to come up with a creative topic and then explore that specifically for that conference. So and it helps me go into areas where I normally don't venture too much during my regular projects. So HoloLens is the natural choice because I'm doing a lot of HoloLens development, and and by making demos, you gain skills to you learn new things that you might be useful otherwise in different projects. So try to come up with an idea first, and then see how far I can go to actually implement it. So.
But you were a previous game developer, or or
not directly game developer. Well, I work a lot with game development technologies for simulation training and training purposes in simulation. So my background is I already work in this industry for 20 years in different kinds of technologies. So with bigger VR systems and simulators. But lately it's mainly HoloLens. Now that I'm doing freelance work, and so it's trying to combine all kinds of things that I combine creatively to create something new, and hopefully something that has not been done before in this way. But yeah,
that's good, because everyone is talking about the skills that needs to have to enter in these VR and AR projects that doesn't exist anymore, and is a conjunction of skills that brings you a good or bad developer of these areas. So I think there is no such a training path that you could do. It's your experience in other areas that bring you to this level of experience, right?
Yeah. Okay. Yeah. It's. I don't know if you cannot make a real black and white distinction when you're ready to do VR. You just have to go do things, and it could be as simple as developing things on for a mobile phone, or using things like the Merge Cube, or much cheaper things. So you can use projectors. The toolbox is much larger than having this certain device that you want to develop for. Of course, that's maybe that's a holy grail to to do development for the best and the most innovative devices in there. But there is the market is much broader than that, and also So I look at all kinds of different devices and technologies, also beyond head-worn devices. So.
All right, that's good. Do you want to speak a little bit more about your work for our audience, and anything that you'd like to highlight?
Unfortunately, most of my work I cannot talk about because of NDAs.
Yes.
So that's why I always decide on building totally different demos for conferences, and well. So
right.
Yeah, the work I can talk about is the personal work I did, and so I like to explore a little bit more into the mixing technology to make art. But lately it's mostly HoloLens work. But I do also work with things like Kinect, etc. For creating interactive installations that people can interact with. And, yeah.
All right, that's good to know.
Mm-hmm.
Now, if you have any further comment, or we can end your session, it's up to you.
Yeah, I'm curious to see if other people start working with the source code, because the source code is available, and yeah, it's all open, so you can see what I did and be creative and think of new things of what you could do, make Timmy do, and or change it for different characters, etc. Yeah.
Yeah, it
It's
would
fun
be
to play with.
nice. Probably you will have comments in the video after the recorded video. You should expect to be good comments on your code. I will try to set up Unity with your code to understand how to do it, and didn't did anything with HoloLens yet, but should definitely try it after
Okay.
what I saw.
Mm-hmm.
All right. So thanks
Thanks
a
for
lot,
having me.
and have a nice evening. All right.
Enjoy the rest of the conference.
Yeah, thanks.